Good day, everybody. How are you all? Today, we are going to talk about basic properties of probability. So, here I go. A probability experiment is one in which we do not know what any individual outcome will be, but we do know how a long series of repetitions will come out. For example, if we toss a fair coin, we do not know the outcome of a single toss will be, but we do know what the outcome of a long series of tosses will be, about half heads and half tails. The probability of an event is the proportion of times that the event occurs in the long run. So, for a fair coin, that is one that is equally likely to come up heads or as tails, the probability of heads is half and the probability of tails is half. The law of large numbers says that as a probability experiment is repeated again and again, the proportion of times that a given event occurs will approach its probability. So here you see a plot where on the horizontal axis you have plotted the number of times you toss a coin, okay, a single coin, okay, you toss it more than one time, okay. And on the vertical axis you have the proportion of heads. So the horizontal line, the red horizontal line is located at y equal to zero point 0.5, or the theoretical proportion of head in the long run, as we discussed in the previous slide, is half or zero point 0.5. So what is the blue line? The blue line is the proportion of heads you are getting as you are tossing the coin more than one times. Okay. And notice in the long run, the blue line, which is the proportion of actual heads, okay, approaches or stays over the red line, which is the theoretical probability of getting a head or probability of a head in the long run, which is zero point 0.5. But there's a lot of fluctuations. Okay. So as the arrows point out, it not necessarily get half head and half tail if you toss the coin 5 times. Okay. If you are tossing the coin 5 times, the blue dot, the proportion of head is zero point 0.6. That means out of 5 tosses, you got 3 heads and 2 tails. But you keep on continuing the toss. Okay. So what happens after 100 tosses? After 100 tosses, the blue line crosses the red line and goes down. Okay. So increase the 100 from 100 going to 1000. What is happening is number of tails are increasing also. So that's why number of heads or proportion of heads is below the red line. But eventually, when we reach 10,000 tosses, the blue line, which is the proportion of heads in your 10,000 tosses, approaches the red line. That means what? That means out of 10,000 tosses in the long run, you'll get 5,000 heads and 5,000 tails. As you would expect, the theoretical probability of proportion of head is 0.5 in that case. Construct sample space. The collection of all possible outcomes of a probability experiment is called a sample space. Describe a sample space for each of the following. Toss of a coin. We know a coin has two faces, a head and a tail. So the sample space is written with that special parenthesis inside the spaces, two possible outcomes, which are head and tail, and then the parenthesis is closed. Roll of a die, there are 6 numbers on the 6 faces of the die. So you have inside the special parenthesis 1, 2, 3, 4, 5, 6. What that means is that any of these number can land face up. Selection of a student at a random from a list of 10,000 at a large university. Sample space consists of 10,000 students in that case. Probability model. We are often concerned with the occurrences that consist of several outcomes. For example, when rolling a die, we might be interested in the probability of rolling an odd number. Rolling an odd number corresponds to the collection of outcomes, or the sample space in that case is 1, 3, and 5. From the total sample space 1, 2, 3, 4, 5, 6. In general, a collection of outcomes of a sample space is called an event. So the event in this case is the getting an odd number, okay, when you roll a die. Once we have a sample space, we need to specify probability of each event. This is done with a probability model. We use the letter P to denote probabilities. For example, we denote the probability that a tossed coin lands heads by probability capital P in parentheses heads. If in general, if A denotes an event, the probability of event A is denoted by P in parentheses capital A. Compute and interpret probabilities. The probability of an event is always between 0 and 1. In other words, for any event A, the lowest value of probability is 0, highest value is 1. That means probability cannot be less than 0 or negative. At the same time, it cannot be greater than 1 or 100%. If A, the event cannot occur, then probability of A is 0. If A is certain to occur, then probability of A is equal to 1. For example, if we know it is going to rain today, then probability of rain will be equal to 1. If a sample space has n equally likely outcomes and event A has k outcomes, then probability of A is number of outcomes in A divided by total number of outcomes in the sample space, which is k over n. What is a good example of that? When we toss a coin, what is the probability of head? How many faces has got head? Is 1. K is 1. Total number of faces is 2. So probability of A or probability of head in this case is 1 out of 2 or 0.5 in the long run. In Georgia Cashflow Lottery, a winning number between 0000 and 9999 is chosen at random, and with all possible numbers being equally likely. What is the probability that all four digits are same? Remember, the four digits are same will be one of the possibilities is 0000. Next one is 1111. Next one is 2222. Then 3333, and so forth till you reach 9999. So there are 10 possibilities. The outcomes in the sample space are the numbers from 0000 to 9999, all the same digits. These are 10 numbers. So there are 10,000 equally likely outcomes in the sample space. I was just talking about same numbers. Actually, the total number of numbers between 0000 to 9,999, there are 10,000 numbers, out of which there are 10 numbers which have the same four digits. There are 10 outcomes for which all digits are same. So, and they've given us, shown us. So, as I said, the first number with all four digits same is 0000. That's a possibility. Next one with all four numbers same is 1111. And you continue this way till you reach the same four digits. The highest number is 9999. So there are total 10 digits, 10 numbers which have the same four digits out of a total number of 10,000. Sample space is 10,000 numbers. So probability all four digits are same is 10 out of 10,000, which is 0.0001 or 1 in 1,000. A penny, a nickel, and a dime are tossed. During denoting a head by H and tail by T, we can denote these three tosses in order. Remember, we are tossing three coins: penny, nickel, and head. For example, HTH means the penny lands head, the nickel lands tail, and the dime lands head. There are 8 possible outcomes: HHH, HHT, HTH, HTT, THH, THT, TTH, and TTT. Assume these outcomes are equally likely. What is the probability that all three are the same? Well, all three are the same are two only, HHH and TTT. Of the 8 equally likely outcomes, the two outcomes are HHH and TTT, correspond to having all tosses the same. Therefore, probability all tosses are same are 2 out of 8 or 1/4. A penny and a nickel are tossed. Each is a fair coin. which means the head and tails are equally likely. Construct a sample space containing equally likely outcomes. Each outcome should specify the results for both coins. What is the probability that one coin comes up heads and the other comes tail? So, the sample space consists of four possible events. It's HH, that means both the coins land head face up, then head tail, tail head, and tail tail. What is the probability that the coin comes up heads and the other comes up tail? Those are two, HT and TH. So the probability that one comes up heads and the other comes up tails is 2 out of 4 or half. Sampling an individual from a population is a probability experiment. The population is a sample space and the members of the population are equally likely outcomes. There are 10,000 families in a certain town categorized as false. Some of them own a house, some of them own a condo, some of them rent a house, some of them rent an apartment. A pollster samples a single family from this population. What is the probability that the sample family owns a house? First, we need to get the sample size, which is 10,000. Out of them, 4,753 own a house. So the probability that a selected person owns a house is 4,753 out of 10,000 or 0.4753. Part B, what is the probability the sample family rents? They can rent a house or rent an apartment, add them two together, 912 plus 2,857 is 3,769. Divide that by the total number of sample size, which is 10,000. An unusual event is the one that is not likely to happen. In other words, an unusual event whose probability is very small. There are no hard and fast rules as to just how small a probability needs to be before an event is considered unusual, but we'll use the following rule of thumb. An event whose probability is less than 0.05 is considered to be unusual. In a college of 5,000 students, 150 are math majors. What is the probability of math then? 150 divided by 5,000 is 0.03, which is less than 0.05. Therefore, the event that the selected student is a math major is unusual. Approximate probabilities using empirical method. The law of large numbers says that if we repeat a probability experiment a large number of times, then the proportion of times that the particular outcome occurs is likely to be the true probability of outcome. Reason is we have repeated the experiment large number of times. The empirical method or the observed method consists of repeating an experiment a large number of times and using the proportion of times an outcome occurs to appropriate the probability of the outcome. In a recent year, there were 313,752 births in the US to low birth weight babies, less than 2,500 grams, while 3,477,960 were babies with weight greater than 2,500. So first we find out the total number of babies born by adding the two numbers. Approximate the probability the newborn baby is low birth weight. So it will be 313,752 divided by the total sample size, which is 3,791,712. And it is 0.0827, which is greater than 0.05. So it is considerable. It's greater than 0.05. 10,000 voters in 100,000 voters in a city, pollster takes a simple random sample of 1,000 of them and finds that 513 support a bond issue to support the public library and 487 oppose it. Estimate the probability that a randomly chosen voter in the city supports the bond issue. It will be 513 divided by 1,000, which is 0.513. Approximate the probability using simulation. In practice, it can be difficult or impossible to repeat an experiment many times in order to approximate a probability with empirical method. In some cases, we can use technology to repeat an equivalent virtual experiment many times. Conducting a virtual experiment in this way is called a simulation. And here they show us how to do it on TI-84 plus, okay, and with Excel. So in this section, we have talked about probability, sample space, and event. And we have talked about how to compute probabilities with equally likely outcomes, the rule of thumb for an event for when an event A is unusual, when probability of A is less than 0.05, how to approximate probability using the empirical method, that is, you repeat the experiment large number of times. Sometimes in reality you cannot do that, then we have to use simulation. So I stop here today. If you like my video, give me a thumbs up. I really appreciate that. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And let YouTube know that you would like to be notified every time I upload a new video, which I do almost every day. And please do not forget to watch me tomorrow when I will load an interesting video, another interesting video. Thanks for watching. Take care. Have a nice day.